Hi, welcome to this course. In this course, we are going to discuss various aspects of mathematics. Also, some other subjects will also be considered. But as you can see for this, we want to consider the various topics and various concepts and aspects of mathematics. And in this course, we are going to explain the various aspects and the course in a very simple and in a demystified way that every student should be able to understand the various concepts that we are going to discuss in this course. And this course is going to be majorly of focus on, is going to focus for any student that is preparing for either your WAEC, your NECO, your JAMB, your JUPEB, your IGMB, and A-level exams. And we are going to go step by step and topic by topic to explain the various aspects, as you can see. I remain the same thing, being your math teacher for this course. My name is Temidayo. Now, we are going to consider the first aspect, as you can have it in syllabus. According to the syllabus, the first topic that we have under the syllabus is number-based system. Now, under the number-based system, these are the various objectives that we need to consider. And what are the various objectives that we need to consider? As you can see, by the end of this course, learners should be able to convert numbers from order bases to base 10. Converting number from order base to a standard base, which is base 10. And the second thing is that convert number in base 10 to order bases. Now, you are now converting number from base 10 to order bases. Then, convert decimal fraction from order bases to base 10. And also we are going to talk about add, subtract, multiply, and divide in order bases. We are very conversant with how we add numbers in our normal standard or base 10 basis. But now we want to look at order base. How do you do that? And we are going to solve various equations in number-based system. Now let's see what we have based on the learning objective for this particular topic. Now we are going to see that when we are talking about number base, we are going to start with the decimal base, which is the counting digits that we are all conversant with. The counting digits, as we are conversant with it, we are going to see how we can use the concept of our counting digits. Now, in the international system of counting, we have basically 10 digits that we use for counting, and that 10 digits means that we are talking about base 10. And in that case, when you are asked to add or subtract a number, or when you are asked to multiply or divide or work with any number, those numbers are given to you in base 10. Now, for this purpose, we are going to start number system. Now, the system of counting in every day is the denary. Now, the denary is the decimal system, which is the base 10. The denary or base 10 system. The digits used in denary system are, as you can have it here, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. When you combine 2 or 3 or 4 or 5 or 6 or all the digits together, we have a number. For instance, I have 24. 24 is a combination of 2 and 4, and this is in base 10, although the 10 is not in all cases identified, but when you are dealing with other bases, we need to identify or show the base that we are working with. And in that case, as you can see, the number such as, look at this number as we have it here, 7,453.872 can be written in place value digits diagram, as you can have it here. Under the place value diagram, as you can have it here, you can see that this is 7,000. That is, as you can have it, 10 raised to the power 3, 10 raised to the power 2, 10 raised to the power 1, 10 raised to the power 0, then you have 10 raised to the power minus 1, minus 2, and minus 3. Now, because at that point, when you are at your decimal point, this is over 10, this is over 100, and this is over 1,000, as you can see. So, that's why you can see 10 raised to the power minus 1, minus 2, and minus 3. Now, we can now write this in expanded form. And that is how we can see it the way we have written it here. 7 times 10 raised to the power 3 plus 4 times 10 raised to the power 2 plus 5 times 10 raised to the power 1 plus 3 times 10 raised to the power 0. Then from here you can see 8 times 10 raised to the power minus 1, 7 times 10 raised to the power minus 2, and 2 times 10 raised to the power minus 3. Now that explains the concept of number base in denary, that is in base 10. Now the same approach, the same method, the same concept can be applied to other bases. And what do we have in that case? Now, apart from base 10, we consider other bases. And quickly, we are going to talk about the other base. We have the binary 16, which is the base 2 16. We have all other bases as we have it, but this special base has the name, which is the binary 16, the base 2 number. We have the base 5 number. We have the base 8. Base 8 is also called octa 16. The octa 16 is the base 8 16 or base 8 number. Then we have the base 12, which is called duodecimal. The base 12 number is referred to as duodecimal, and we have the base 16 number, which is hexadecimal. Now, those are the special decimal that we have. Now, when you are talking about numbers in base 12, now, as you can have it here, the number in base 10 ends at 9. So when you have a number in base 9, you have 1, 2, that's 0, 1, 2, 3, 4, 5, 6. Then you have your 6 here, 6, 7, 8, 9. This is where we have your base 10 number, the last number in base 10. So when you want to represent other number apart from base 10, now base 11, this is where you have your base 10. From this point, you have base 10. This is where you have your base 10. Now for base 11, you have A. A represents 11, and you have B. B represents your 12. Also, we have C. C represents your base 13. You have D, which represents your base 14. You have E, which represents your base 15. And you have F, which represents your base 16. So that is how you have the other bases being represented. As you can see, base 11 is A, and base 12 is B, base 13 is C, base 14 is D, base 15 is E, and base 16 is F. Now this is hexagonal, and that is where we are going to limit ourselves for this course. And stay tuned, we are going to see other aspects just like what we have said in explaining what we have here. Now notice that the greatest digit used in number system is 1 less than the base. What do we mean by that? The greatest number you can have in any number system is 1 less than the base. That means in base 2 number, when you have a base 2 number is going to be 2 minus 1, and that is 1, which implies that we can only have 0 and 1. That's 2 digits in base 2 number. Also, if I consider base 4 number is going to be 4 minus 1, and that's going to be 3. So which implies that I can have 0, 1, 2, and 3 in base 4 number. So the same thing goes on and on and on for other bases. For instance, in base 11 number, the highest number I can have in base 11 number, that is when I'll be having 11 minus 1, which is 10. That means I can have up to the 10 digits as we have it here for base 11 number. So that is what we need to understand as the introduction or the basis of what number system is all about.